Hey everyone, and welcome to today's challenge video. For today's challenge, we're actually going to go over something kind of simple, but could be kind of hard to fully conceptualize in your head if you're first starting out with this new structure. So what it is we're going to find the middle element of a singly linked list and return its value. So the problem is, given a singly linked list, find its middle element. If there are an even number of nodes, then there are two middle nodes. Return the second middle element in cases like this. And then, for example, it gives us an array, which basically is just giving us an array of the values that are stored in the singly linked list. And basically just saying that if we get this array of nodes, we get that in return. So in case we get 5, 4, 3, 2, 1, we're going to return back 3, since the middle would be the third technical digit in 5 set. If we have a set of 6, like 10, 8, 4, 4, 10, 8, 6, 4, 2, 0, 6 and 4 are our two middle digits, we're going to return 4. That's just how it's just going to go. And the code for us is kind of built out a tiny bit. It's giving us the class structure of the list node. And usually this is typically what a singly list node would have. You would have a constructor of the list node just that sets the value of the node itself, and then you have it be able to see what comes next. And I'm going to draw this out in a structure for you. So if we go to our paint, a singly, not drawn yet, so a singly linked list is like if I have a box, my box has a value n, and my value is n, so my val equals n. The only other thing that this thing can see is what comes next. So if I have another box of m, this can only see what comes next. K, and K can see what comes next, which would be L. And we're going to say that L is the last thing, so L doesn't see anything, so it just says there's nothing there. But it doesn't see the other way, which would be a normal linked list or a doubly linked list. A doubly linked list would be if I have n, m, well, this is a singly linked list, a double linked list. A double linked list that says that n can see m and m can see n. So we kind of know how many options are in this list. N can see m can see n, so we know that there are two. Basically, we can see that there is going to be a circular pattern here, that we can go from the start to the end, and once we know that, we can figure out how many items are actually in it. There might actually be a value to know how many items come after this. That might be a known thing. But in a singly linked list, we have no clue how many items come after this. We don't know how many items come after n. We don't know how many items come after m. We don't know how many items come after k. Nor do we know how many items come after l. So what we need to do for this project or this issue is we need to, one, go through or loop through the entire list, the entire list. However, what you need to do prior to that, so let's say step 0, save a pointer to the first node. Because what we're given is the first node. If we're not saving that node and we just go to next, we now no longer have access to this node. If we go next past that, we no longer have access to either of these nodes. And in Java, and in some other languages that have automatic garbage collection, those items will be collected by garbage. If they aren't collected by garbage, then they're just stuck storage that will never ever be used, and your storage capacity will just increase exponentially as you're going through. So we need to loop through the entire linked list, count the amount of items. I'm only getting worse. My handwriting. Divide by 2. Divide count by 2. Count 2, and then for loop through count and return value. So we need to loop through that count and return the previous value. Now there is one caveat to this that says if we have a even list, then we have 2 items in the middle. So let's say we have an item of 6, like a length 6 of a linked list. Items 3 and 4 are technically in the middle. We want to return 4, not option 3. And that all goes built into how you loop through your entire code. So that's how I'm going to actually get into this. I'm going to have an index of 0 for my code, and I'm going to loop all the way up until I hit the point on which I can't loop anymore. So I'll go count in. And if I go count in, that mathematically always puts me at the second middle list item if I happen to be at a even size array list, or even size linked node list. So I'm going to create a list node of integer. I'm going to indicate this as first, and I'm going to set it to F. Then I'm going to create a for loop. Secondly, I'm actually going to count, set that to 0, and I'm going to make for loop for node, and I'm going to set it equal to an integer. Say this is PTR equals L. So technically first and L are the same. First, PTR, and L are all pointing to the same thing. However, first points to L and that gets stored elsewhere. So that's technically a duplicate. PTR is a new version of this also pointer. However, if I modify PTR, I'm not modifying first. First has that same story. So we're not really changing first, we'll be changing PTR. I'm going to say while PTR is not equal to null, and PTR equals PTR.next, which will bring us to the next item. And what I'm going to do is I'm just going to increment count, plus. I'm going to increment count the entire time. Then I'm going to divide count by 2. And then I'm going to go through the list again. So I'm going to say int I equals 0, I less than count, I plus. What I'm going to do is I'm just going to move first the entire time. First. I'm going to keep moving first along. I'm going to increment it through the linked list all along. And I'm just going to return first dot value to return the value of our linked list. So what this is doing, I am setting the linked list or creating a pointer that points to the first item in the linked list. Then I'm creating a count that will determine how many items are in the linked list. I set a new pointer to the first spot of the linked list, and I move that pointer throughout the entire linked list. And from there, I know the count. Then what I'm doing is I am dividing that count by 2, setting it equal to itself. This is going to truncate the half that we get if we get a number, and that automatically puts us at the next spot. So basically what we've created is an array, or how we're viewing this is we've created an array. And what I'm doing in this next for loop is I'm looping through the new array type structure. I'm doing this in quotation marks. New array type structure that we've created. Count times to get to the position that we want within the linked list itself. And then I'm just going to be returning that value. So for this example, I create a pointer. I figure out that the distance is 5, or the amount of items in here is 5. I divide that by 2, so I get 2.5, but it's an integer, so I truncate it. And then I'm going to go in here as though it is starting at 0 and go 2 items in. So I need to go to position 2, so 0, 1, 2, and I'll return this 3. And that will give me the correct answer. So if I run my sample tests, this should pass every single sample test, and it does. And then if I click submit, this should be the correct answer. And it is the correct answer. So this is actually how you can get the middlemost item or the middle item of a array or a linked list, knowing that it's only a singly linked list. So thank you very much for watching. I highly hope you enjoyed this video and have come out of this a little bit more knowledgeable on singly linked lists. If you haven't, please leave a comment so I could try to explain it further for you. But if you have, also leave a comment telling me how well you know this now. All right, thank you very much.